Hello, everyone. My name is Riley Dickens, and I'm a consultant with Encryption Consulting. Today, I have a webinar for you that discusses our Cloud Data Lake protection tools on Google Cloud Platform. Our agenda for this webinar begins with understanding the Cloud Data Lake and its data phases. We will then move to demonstrations of Encryption Consulting's tools to protect data on the cloud. First up is our introduction to the Cloud Data Lake. The Cloud Data Lake is becoming increasingly more relevant every year as more and more organizations move their infrastructure to the cloud. The Cloud Data Lake has several phases for data, including an ingestion, storage, and processing phase. Since data passes through so many different phases in the Cloud Data Lake, there are many different attack vectors for threat actors to target. For this reason, Encryption Consulting focused on creating a suite of utility functions that protect data at different stages of the Cloud Data Lake data lifecycle. Cloud Data Protector is a tool that encrypts, masks, replaces, or redacts data that is ingested from on-premises systems to Google Cloud Platform, or GCP. The phase Cloud Data Protector, or CDP, protects is the data ingestion phase. Bucket Protector is a tool deployed in a Google Cloud storage bucket to safeguard data in the storage phase. Finishing off our suite of utility tools is BigQuery Protector. BigQuery Protector works with GCP's BigQuery to query large datasets stored on the cloud. BigQuery Protector allows for searching or insertion of either encrypted or decrypted data into a database. Here, you can see how our utility functions work in conjunction with each other. Later in our presentation, I will provide you with a demonstration of our tools in action. I will show you how data can be migrated to the cloud into a database, with the sensitive data being protected along each step on its path. Data will initially be ingested via CDP into the cloud. That data, which will be stored in Google Cloud Storage, will then have encryption, masking, replacement, or redaction done to any sensitive data in the dataset via Bucket Protector. Finally, after the data is uploaded to a database, I will demonstrate BigQuery Protector's querying and data insertion capabilities. The first function I will discuss is Cloud Data Protector, which works at the data ingestion phase. CDP focuses on data being migrated or stored in Google Cloud Platform. Users deploy this tool within their Google Cloud account via either their local machine CLI or the Google Cloud UI. This tool protects data being moved from on-premises systems to the cloud. Users have the ability to choose either format preserving encryption, masking, replacement, or redaction of sensitive data within their dataset before it is transferred to the cloud. Safeguarding data in this way ensures your organization meets compliance guidelines like FIPS or PCI DSS. Here, we have an architectural diagram explaining how CDP works. Initially, the structured or unstructured data is passed to Cloud Data Protector. The user then prepares a configuration file containing the path to the key, keys that need to be used, the columns of data, as well as the method each column should undergo. The available methods to use on data are format preserving encryption, data masking, replacement, and redaction. The config file and dataset are then passed to the DLP API. The Data Loss Prevention API implements the necessary methods, and if FPE is used, then the Key Management Service API is used to retrieve the encryption key. The newly protected dataset is then passed to the user and can be safely transferred to Google Cloud Platform. If FPE was used, then a wrapkeys.json file is also created to be used for FPE decryption. Now, let's take a look at this tool in action. First, we'll go to our GitHub page and download the necessary files to our desktop. Go ahead and click right here and click Download Zip, which I've already done. I've extracted that file onto the desktop, and as you can see, it should have all these files minus this JSON file for now. And I've also put my data set in here as well. Here's the original data in here, all false data, of course. Otherwise, this is all that should be downloaded. The first thing you'll need to do is take a look at our documentation, which is included with the zip download, and download Python. I've already downloaded this ahead of time. I'm working on Windows, so I'll follow all the steps for Windows as opposed to the Linux ones. So I'll go ahead and cd into our folder on the desktop and run the command pip3 install -r requirements.txt. And since I've already done it, all of this has been downloaded already, but you can go ahead and run that and it should download all the necessary packages. The packages include TQDM, gRPCIO, Google Cloud DLP, and Google Cloud KMS. Now we'll go over to our browser and enter our Google Cloud project. This is the project I'll be using, and you can select from your projects here as well. So here, this will be important later on, but this is where your project ID will be. Just click here and you can see it. And now we'll go ahead and type in KMS. We're looking for this KMS API. And we'll need to activate this as well as the DLP API. Now I've already enabled this, but there should be an enable button instead of a manage button. So you'll go ahead and enable it, wait a moment, and it should come to this. And then we can go ahead and click back here and type in DLP. And again, we're looking for this cloud loss data loss prevention API. And click here and do the same, enable. For me, again, I've already enabled it, but you'll see an enable button as opposed to a manage. Now that you've enabled the DLP and KMS APIs, we'll go to our documentation and run this command. Now, this command will be run from the Google Cloud Shell, which you can find right here. It's grayed out for me because I already have it open. So if you go in here, you can see I've already have it typed out. Now, something important to note is that when you copy and paste this in, ensure you replace your project ID with this one, as well as here. And this should be the current location you're in. So we'll run this and get a permission denied error. As long as you get this DLP API service account error, unable to read from this path, then you know it worked correctly. So now that we've done this, if you're using format preserving encryption, I'll show you how to create keys and key rings. It's pretty straightforward. You were looking for the security tab here. I have it pinned, but it's normally right here. So you'll go ahead and hover over this and go down to cryptographic keys. And under cryptographic keys, you'll see the key rings and the keys that they relate to. Now, I've already created my test key ring, but I'll quickly show you how to make one. You'll go ahead and click Create Key Ring. You'll go ahead and name your key, Test Key 12, and make sure the location is global. You'll then create the key ring. And within that key ring, you'll create a key. You'll give it a name. You'll give it this, leave the software level, leave the purpose, everything the same. And then click Create. And you'll go back here and you'll see within your new key ring, if you created a key, the newly created key. So these are the names, new test key ring and new test key, that we'll use when we work with the template later. But before we do that, we'll need to go to the IAM and admin tab. This is also located at the very beginning if it's not pinned for you. Now we'll hover over and go to service accounts here. And I've already created the test service account, this test account. But again, I'll show you how to create one. You'll put in your service account name and the service account ID will be generated for you, or you can pick your own, but I would suggest keeping the service account ID. So here's my fake one. You can give it a description. And here, it's extremely important that you scroll down to DLP and make this a DLP admin, as well as going down to Cloud KMS and making this a Cloud KMS crypto key encryptor and decryptor. Now we'll continue on. And for this, you're going to want to give this to your main account, so the account you're logged in as. So for me, it's ec@encryptionconsulting.com. And the same as well for the admin. So now you'd click Done, create this account, and as you can see, here it is, and it has no keys. Now, the account I'll be using already has a key, this test account, Riley. We'll need this key. So what you'll do is you'll click on the account and go over to keys and click Add Key, create new key in JSON format, and click Create. And then you're going to want to go ahead and save this key to either a path you can remember. I personally prefer to save it in the Cloud Data Protector main folder with everything else. So here you can see my previous key is set, and now we'll move on to the template. So if you open up your template.json, normally it's empty. It has this project section and the project ID and everything is blank, but it leaves you with all these different choices. So I'll go through mine step by step. So here is the project ID, which we saw on that previous page. Here, you'll put in the path to your data set. So mine is located in the same folder, and it's testdataset.csv. Ensure when you're putting in a path that you do double slashes, because with just single slashes, it will error out. The config name is the name of the key JSON file you just downloaded, and this is the path to it. Again, remember those double slashes. Now, if you're using FPE, which I am, you'll need to put in the key ID and the key ring ID. If you're not using FPE, then go ahead and leave these as none. Finally, we come down to the methods. So as I previously mentioned, you can do replacement, FPE, masking, or redaction, or you can just leave the column alone. You're going to want to specify this for each column, and here you'll put the column name, the method. So for this, it's none, so it needs no more parameters. For the replacement method, you're going to need to put in an info type. Now, the info types can all be found online by Google Cloud, and this tells you what to put within those quotes. So you can see here, I want to replace the column phone number with the string false string, and this is what the info type looks like. Now here is the social security number column. I'll be using the method FPE, and this just requires an info type. For masking, however, you need an info type, the character that you'll be masking that info type with, and how many characters to mask in that info type. So every email address will have the first 5 characters masked with a star. Finally, there's redaction, which also only requires an info type and the column name. So once you have this saved, make sure it's in the same folder as main.py to our command prompt, and we'll type in Python main.py template.json. Now, again, ensure that you're in the command prompt in the correct directory where the main and the template files are located. You're going to want to make sure, again, that you have Python downloaded, and you're going to go ahead and run the main Python script along with that JSON file. Go ahead and hit enter, and it'll load. And as you can see, we now have a test dataset protected file, as well as a wrapped keys.json. The wrapped keys file contains the name of the file that was encrypted with format preserving encryption, the key ID and key ring ID of the keys used, as well as the wrapped key. Also, we can compare the original data to this newly protected data. So here you'll see that we have the names all left alone. All of the phone numbers have been replaced with the false string. The social security numbers have all had format preserving encryption done to them. The email addresses have all had their first 5 characters masked with the star. All of the credit card numbers have been redacted. Next up is Bucket Protector. This cloud utility function guards data in the data storage phase. Bucket Protector works with Google Cloud Storage to ensure sensitive data stored on Google Cloud Platform is kept secure. Bucket Protector utilizes a template file to learn all the methods to be used on the dataset. These methods can be format preserving encryption, data masking, replacement, or redaction. Once the sensitive data is successfully protected, that data can then be moved throughout other GCP tools, like databases, without fear from the user that their data is unprotected. Once the sensitive data is successfully protected, that data can then be moved throughout other GCP tools, like databases, without fear from the user that their data is unprotected. The below image is meant to assist you in visualizing how the components of Bucket Protector interact with each other. Initially, the end user sets up the Google Cloud function on their GCP account. This involves setting up a deployment, protected, and raw data bucket. The raw data bucket takes in the raw data and triggers the cloud function when data is uploaded to the bucket. When the raw data is uploaded, the Google Cloud function reads the template to understand which data protection methods to implement on the dataset. These methods are then sent to the DLP API, and the sensitive data is guarded. If FPE is utilized, then the DLP API works with the KMS API to utilize keys for encryption. Once the data is fully protected, it is placed into the protected data bucket. To understand Bucket Protector better, I'll give you a short demonstration of it in the case of data migration. To begin, we'll go to the Encryption Consulting GitHub page. Under Bucket Protector, you'll find all the tools you need to run Bucket Protector. Here, under Releases, you'll see version 1.0, and you'll go ahead and download the source code. In the source code, you'll find the Bucket Protector file, the zip file, the documentation, as well as this cloud-func-config.json file. To begin, we'll go to your Google Cloud account. Here, you'll find the project ID at the very beginning, and we'll start by activating the DLP API and the KMS API. As you can see, I've already enabled it, so it says manage, but yours should say enable there. Once that has been enabled, we'll go back to the search bar and look for KMS API. Once you find KMS API, click enable, and again, I already have this enabled, so it says manage for me. Now, we'll go over to the navigation bar and create our buckets. You need to create 3 buckets, one for deployment of the Google Cloud function, one to trigger the Google Cloud function, and a third to put the protected data in. The way to create a bucket is by clicking Create Bucket. This is just an example of how to create a bucket, but you'll use these exact parameters to create all 3 buckets. First, give a unique name to your bucket. Then you'll store your data regionally in your location. Here, we'll leave standard as the storage class. We'll select fine-grained for access control. And everything else will leave the same. Once you've created 3 buckets with these exact standards, you can move on to creating your keys. To create cryptographic keys, and this is only if you're doing format preserving encryption, you'll go to cryptographic keys under security. I have it pinned here, but you can find it right here at the very beginning. And you'll create a keyring. Name your keyring, ensure that the location is set as global, and create a key as well that is globally accessed. Once you've done this, we'll go ahead and create the Google Cloud function. I have it pinned here, but scrolling through this list, you should find it right here under serverless. To create a Google Cloud function, you'll select Create Function, enter your function's name, select the region you're in, and change the trigger type to Cloud Storage. Next, we'll change the event type to Finalize Create and select our bucket that will trigger this function. My bucket here is named Trigger Bucket. Now we'll save and click Next. This is where the code comes in. First, we'll select the runtime, Java 11. We'll select Zip Upload. Here, you'll have to select the myapp.zip file, which is located in the bucket protector zip. Here, I've extracted it to the Downloads folder. You'll select it and click Open. And for Stage Bucket, you'll pick your deployment bucket. Finally, we'll need to put our entry point. The entry point is titled com.mycompany.encryption2bucket. Once you've entered the entry point, we'll select Deploy and wait for the green check. One other step we need to do is go to the IAM tab and select the correct permissions for our account. What we need to find is the App Engine default service account. We need to ensure that it has the Cloud KMS crypto key, encryptor decryptor, DLP admin, and storage admin permissions. You can edit permissions of this account by clicking the pencil on the right. Once you've selected all the permissions, we'll hit Save and go check on our Google Cloud function. Now that the Google Cloud function has successfully deployed, we can test it. To do this, we'll need to first open the cloud.config.json file. Inside, between all the quotes, it will normally be empty, so you'll have to fill that in yourself. For project ID, you'll want to put your own project ID found on the main page of Google Cloud. Location ID should be the location that you selected for each bucket. Protected bucket should be the name of the bucket that you selected to put the protected data. For methods, you'll have to enter in each method that you want to do. You can do one method, you can do all 4 methods, it does not matter. One method could do all the sensitive data as long as you separate the info types with commas outside of the quotation. For my example, I'll be trying each data protection method. If you select replacement, you'll have to enter in any info types you want replaced, as well as the replacement string. For format preserving encryption, you'll need to enter in each info type that you want encrypted, the surrogate info type, the wrapping key, and the wrapping keyring. For data masking, again, you'll enter in all the info types you want masked, you'll enter in the masking character, as well as the number of characters to mask with that character. Finally, if you select redaction, all you need to put in is the different info types you want redacted. Now that this has been filled in and saved, we'll go ahead and go back to Google Cloud. Navigate to the cloud storage, and inside, select the bucket that acts as the trigger bucket. You'll enter that, upload files, and enter the cloud.config.json file. The Google Cloud function is set so that if this exact file is uploaded, it will not set off the function. It needs the test data set before it can do that. Give it a few moments and then upload your test data set. You'll know that the Google Cloud function has successfully run when inside the protected bucket is the protected data set as well as wrappedkeys.json. The wrappedkeys.json file shows you the key as well as what that key encrypted. This is for later decryption of FPE. Looking at protected dataset.csv, you can see that all the data has been protected. Credit card information has been encrypted, email addresses have been redacted, social security numbers have been masked, and phone numbers have been replaced. Now, we're moving to our final utility tool, BigQuery Protector. BigQuery Protector works with Google Cloud Service BigQuery, which is used to query databases on the cloud. BigQuery Protector takes BigQuery a step further, allowing you to query data in an encrypted database. With this tool, you can search a database or insert into a database normally, or you can encrypt data and insert it into the database, or search for encrypted data. This encrypted database querying allows users to search for a specific user, for example, without revealing their other sensitive information. BigQuery Protector can be deployed as a standalone or containerized service in Kubernetes, as a library embedded with a service, or as an executable tool. Here's a diagram of how BigQuery Protector architecturally works. As an executable tool, the user enters the BigQuery Protector query into the tool via Google Cloud Shell. That query is then sent through a query translator to translate it into a true BigQuery query. The query is then executed via BigQuery, and the necessary information is then sent back to the user. The goal of BigQuery Protector is to protect data from both outside attackers as well as the service providers of the database as a service. The data is encrypted with format-preserving encryption on the client side and then transferred to the service provider. As much processing as possible is done on the provider side with the encrypted data. Decryption and the remainder of the query process are done on the client side, thus protecting the data from the service provider. My demonstration for BigQuery Protector will be of its executable tool usage through Google Cloud Shell. To begin, we'll go to our Google Cloud project. Here, you'll open up Google Cloud Shell by clicking this. Enter the directory you'd like the executable tool to be in, and then go ahead and git clone the link. You can find this link by going to the BigQuery Protector GitHub, selecting code, and copying the HTTPS link. Once it's copied, you'll paste it here, and the executable tool will be entered right in this directory. You can see that I've entered it into my testing directory. Once you git clone the project, you will get this BigQuery Protector folder. CD into that folder, and you'll see several Python files. To use this tool, you will type ec space ec-bigquery.py. This opens up the SQL query selector. I've already created a test data set, which I will show you with the select command. The select query works the same as a normal select query. It will display everything, whether it is encrypted or not, within the database. Here, you can see the values already encrypted, along with the ones that have not been encrypted. As I mentioned, data can be viewed and inserted normally as in regular BigQuery. I will display that now. As I mentioned before, data can be viewed and inserted normally as in regular BigQuery. Here, I'll display the database and show only the name Ryan. As you can see, all of the values of Ryan that are not encrypted show up. These values, 1 and 2 and 3, are all also Ryan, but since they're encrypted and the EC access command was not used, you cannot tell. Now, we'll run insertion with just a regular name. Here, I will do insert into the database. Here, I'll enter the values, which include the name, Stephen, Stephen's sex, male, as well as the count value. Here, I'll show you that Stephen was successfully inserted without being encrypted. I'll run the same command as previously to show you the whole data set. Down here, you can see Stephen male 9086 was entered. Data can also be viewed and inserted with encryption in place. Here, I'll use the same command, but with EC access to display only the encrypted version of Ryan. Here, you can see that the 3 encrypted values of Ryan were displayed, but not the decrypted version of Ryan. Next, I'll show you how to insert an encrypted value. As you can see, the value was successfully inserted. Here, as with the select command, I've used EC_access around the name or the value that I want encrypted. Using the same command as previously, you can see the 9087 value of Stephen has been encrypted. By default, when running the EC access command to view encrypted data, the data is shown as an encrypted value. If, however, you set the output value to decrypted, then the same query will show the decrypted version of the data. Here, you type in output equals decrypted. By default, it is set to encrypted. So in this way, as long as you have access to the keys for encryption, you can view the data decrypted. As you can see, that same output, Stephen male 9087, has been shown without the encrypted value. This will only decrypt the value within the EC_access parentheses. That's it for our webinar today. To learn more about Cloud Data Lake Protection and our Cloud Data Lake Protection products, visit our website at encryptionconsulting.com/cloud data lake protection. Thank you.